Hello, welcome you all. I am Dr.Paramashivaiah, Associate Professor in Mechanical Engineering Department, Canara Engineering College, Mangaluru. So, for today's topic for the session is engines. What is an engine? Engine is a machine which converts heat energy liberated by combustion of fuel into mechanical energy or mechanical work. So, here the chemical energy possessed in the fuel is converted into first heat energy, and then it generates a lot of pressure, that is heat energy into pressure energy. That pressure energy is exerted on the piston in a reciprocating engine. The piston reciprocates inside the cylinder, thereby converting the heat energy into pressure energy and then to the mechanical work. So these IC engines, reciprocating internal combustion engines, can be classified in different ways. So we will see the various ways how we can classify the IC engines. The number one, based on the fuel used for the engine, they may be classified into petrol engine, diesel engine, gas engine, and biofuel engine. Then classification of IC engines based on the thermodynamic cycle adopted in the working of the cycle. We can classify into Otto cycle engine, diesel cycle engine, and dual combustion cycle engines. Then based on the number of strokes, the IC engines can be classified into four-stroke engines and two-stroke engines. Then based on the method of ignition, engines can be classified into two categories. One is a spark ignition or SI engines, then compression ignition or CI engines. Then number six, based on the position of the cylinder, we can classify the IC engines into horizontal engines, vertical engines, V engines, opposed cylinder engines, and the radial engines. And finally, based on the method of cooling adopted to cool the engine, we can classify the engines into air-cooled engines, water-cooled engines, and oil-cooled engines. Okay, this animated video represents the working of a four-stroke engine, four-stroke internal combustion engines. It is called four-stroke because to complete one complete cycle, it makes four strokes. So during these four strokes, it rotates the crank two rotations. So one complete cycle, so four strokes, two complete rotation of the crank or wheel. So such engines are called four stroke engines. So then what is a stroke? Stroke is the reciprocatory motion of the piston, reciprocatory motion of the piston. So this is the piston which is reciprocating inside the cylinder. This is the cylinder. Inside the cylinder, so it is reciprocating. This is the piston and this is the cylinder inside which the piston is reciprocating. So what is a stroke? Stroke is the one movement of the piston from the two between the two ends of the cylinder. The two ends here are the topmost point to which the piston can reach is called top dead center, and the bottommost position or the point to which the piston can reach is called bottom dead center. And one movement of the piston from bottom BDC to TDC, or maybe from TDC to BDC. The one complete motion movement between the two ends is called one stroke. One stroke. So then now we will see how a four-stroke engine works. The major components are, this is the piston which reciprocates inside the cylinder, and this is the connecting rod which connects the piston with a crank. This is the crank. The crank, it's a mechanism which is used to convert the reciprocatory motion of the piston into rotary motion. The motion required for all engines is a rotary motion, But available motion here is reciprocating motion. So this reciprocating motion is to be converted into rotary motion. For that, the arrangement of this connecting rod and crank is adopted. How it converts, we will see later. So then it consists of, say this is inlet manifold, means through which air fuel mixture is drawn into the cylinder. Hmm? So for drawing that, there is valve. This is the valve, inlet valve. So through which air fuel mixture is drawn into the cylinder. Hmm? So then this is the exhaust manifold. So through which the product of combustion, when the fuel is burnt inside the cylinder engine, so the products of combustion, maybe carbon dioxide and other gases, they are thrown out through this manifold, which is called exhaust manifold. And this is the valve which opens during the exhaust stroke, means to throw out, to flush out the products of combustion. So these are the major components. Now we will see how a four-stroke engine works. Now this blue color indicates the low temperature air or air fuel mixture taking into the cylinder. So now stroke number 1, you see the suction stroke wherein this inlet valve opens and air or air fuel mixture is drawn into the cylinder, and during which the piston moves from TDC to BDC. This stroke is called suction stroke, where air or air fuel mixture is drawn into the cylinder. Once it is drawn completely, the inlet valve closes. Then exhaust valve, this is also closed. So then the air or air fuel mixture cannot escape through the valves. So then during that, the piston moves from BDC to TDC. So during this movement, it compresses the air or air fuel mixture inside the cylinder. This stroke is called compression stroke, during which air or air fuel mixture is compressed to high temperature and pressure. Now you observe at the end of this compression stroke, so there is a spark. The spark is ignited in order to burn the fuel. Okay. So in case of petrol engine or in case of a diesel engine, so instead of spark, there will be a fuel injection. Diesel is injected at high pressure, so into this air which is compressed to high temperature and pressure. So then power stroke starts. There will be combustion of the fuel, generation of heat, then rise in the pressure. The pressure is acted on the piston. Piston moves down. That stroke is called power stroke. So during which the piston moves from top dead center to bottom. That is power stroke. Number 3. Number 3 is power stroke. Then exhaust stroke. So during which piston moves from bottom dead center to top dead center, during which the exhaust valve opens. Now the fourth stroke, you observe, exhaust valve opens, and the product of combustions, gray color, they are flushed out through this manifold, exhaust manifold. So these are the four strokes. So number 1 is suction, 2 compression, 3 power stroke, 4 exhaust stroke. These are the 4 strokes of the engine. So during these 4 strokes, the crank rotates 2 rotations, and this engine completes one cycle of power stroke. So therefore, this type of engines, so which take 4 strokes to complete one cycle, wherein it gives 2 rotations to the crank. These are called 4-stroke engines. I hope it is clear. Now, from your examination point of view, you may have to draw this diagram and explain. If the question is with any diagram, explain various parts of an IC engine, then you are supposed to draw this diagram neatly and explain. So this consists of basically, so this is the crank case, this is the case, engine case. So there is at the center there will be a shaft, circular rod. Shaft is a circular rod. So then it is connected with a crank. The crank and connecting rod. Connecting rod is one rod which connects the piston with the crank. So this arrangement is required to convert rotary motion of the piston into, reciprocating motion of the piston into rotary motion. Okay. So the connecting rod connects the piston with the crank. Piston, this is the piston which reciprocates between two ends, top dead center and bottom dead center. So of a cylinder, this is called the engine cylinder. This is the engine cylinder. Okay. Then at the top there are two openings. So this is called inlet manifold, through which suction of air or air fuel mixture is done. And to allow that, there is a valve called inlet valve. When it opens, suction takes place. When it closes, it will not allow anything to enter into the cylinder. Then this is another manifold which is called exhaust manifold. So through which the product of combustions are expelled or flushed out, and this is the valve called exhaust valve. When it opens, then it allows the products of combustion to flush out into the maybe silencer. And here this is at the center a spark plug or a fuel injector, diesel injector. In case of petrol engine, this spark plug provides the required spark at the end of compression. So when at the end of compression, wherein the air and fuel mixture is compressed to high temperature and pressure, this spark plug generates a spark, creates a spark, and it initiates the combustion of the fuel. So in case of diesel engine, so only air is drawn into the cylinder through the inlet manifold during suction stroke. Then that air is compressed to high temperature and pressure. At the end of compression stroke, a fuel injector injects the diesel at high pressure. So then it starts burning, combustion takes place, pressure is exerted on the piston by the products of combustion, which makes the piston to move down, that is called power stroke. So these are the various parts of a reciprocating internal combustion engine. Next, now we will study different engines one by one. First, we will take up a 4-stroke petrol engine. As I told you, but in case of petrol engine, air fuel mixture is taken into the cylinder. So prior to this, there will be another device which is called a carburetor. Function of the carburetor is to take fuel from the fuel tank, air from the atmosphere, and it mixes the air and fuel. A uniform homogeneous mixture of air and fuel is prepared, and then it is supplied through the inlet manifold to the cylinder during the suction stroke. So now to explain this diagram, so this is the cylinder, and this is top dead center, and this is bottom dead center. This is the piston which is in red color, and this is the connecting rod which connects the piston with the crank. This is the crank. The crank rotates when the piston reciprocates. Okay. So then this is called a crank end, and this is the cover end, top end, piston. So now, and this is inlet manifold, this is exhaust manifold, and here is a inlet valve, and here is the exhaust valve, and this is spark plug. So first stroke of these four strokes is suction stroke, wherein this inlet valve opens, piston moves from top dead center towards bottom dead center, means top to bottom. Then this crank rotates through 180 degree, half rotation. One stroke of the piston leads to half rotation of the crank, during which inlet valve opens. It draws in or sucks in air fuel mixture. Okay. Then, so this indicates the first stroke, suction stroke. Now see at this point, it is end of suction stroke. Suction stroke is over. So inside the cylinder there is full mixture of air and fuel. Okay. So then starts the compression stroke, stroke number 2, during which both the inlet valve and exhaust valve are closed. Piston moves from bottom to top dead centers, during which it compresses the air fuel mixture to a high pressure and temperature. So then at the end of compression, see here at the end of compression, a spark is generated by using a spark plug. The spark ignites the fuel and then combustion starts. After combustion, heat is liberated. That heat increases the pressure of the products of combustion. That pressure is acted on the piston of the engine, and then this piston starts moving from top to bottom dead center. That stroke is called power stroke. Then at the end of this power stroke, see this indicates the end of power stroke. Piston is at bottom dead center, hmm, during which again the crank rotates on 180 degrees. Okay. So then at the end of this, see here exhaust valve opens. This remains closed. Inlet valve remains closed. The piston moves from BDC to top dead center. So during which exhaust valve is opened, the products of combustion are thrown out to the silencer. So these are the four strokes. Stroke number 1 is suction stroke, wherein air fuel mixture is drawn into the cylinder. Number 2, compression stroke, where the air and fuel mixture is compressed to high pressure and temperature. At the end of compression, a spark is generated, and power stroke from TDC to BDC, stroke number 3. And then fourth one is exhaust stroke, wherein products of combustion are thrown out. So during each stroke of the piston, crank rotates 180 degrees. Suction stroke 180, compression stroke 180, power stroke 180, then exhaust stroke 180. Totally, the piston rotates, a crank rotates 2 rotations. Piston makes 4 strokes, and the entire cycle is 1. One cycle, one power stroke, then 4 strokes, suction, compression, power and exhaust, 4 strokes, 2 rotations of the crank. So this is how a 4-stroke engine works. So that is why, because there are 4 strokes in one cycle, the engines are called 4-stroke engines. So it is a petrol engine. So here the fuel used is petrol, or either petrol or gasoline, or it may be LPG or CNG, whatever it is, even alcohol, all these. So here this is the air standard cycle. This diagram represents pressure versus volume chart during the cycle. This cycle is called Otto cycle. All petrol engine works on the Otto cycle. So it consists of different processes, thermodynamic processes, and this is one complete cycle. Observe process from 1 to 2, wherein volume increases from V1 to V2. It is a suction stroke. Suction of air takes place. Yeah, air fuel mixture takes place into the cylinder. Then 2 to 3 is compression stroke, where the air fuel mixture is compressed from 2 to 3. Volume you see V1 equal to V3, compressed. Then ignition takes place, combustion takes place, say at constant volume, heat is added. That is 3 to 4, you see, observe, volume is constant, V3 equal to V4. Combustion takes place, fuel burns, and heat is added to the cycle. Then 4 to 5 is expansion. That is nothing but power stroke. The volume increases from V4 to V5. This is the power stroke, which develops the power. Okay. Then 5 to 6 is, observe, volume remains same. V5 is equal to V6. Constant volume, heat rejection process. Then 6 to 1 again exhaust. So these are the various processes of the cycle. Cycle is called Otto cycle, in which heat addition takes place at constant volume. Heat rejection also takes place at constant volume. So this is also called constant volume cycle or Otto cycle, and this is designed by an engineer called Otto. So the name is given after him, Otto cycle. All petrol engines work on this cycle, Otto cycle. So now we will see how a four-stroke diesel engine works. So first, I would like to tell you the major differences between a diesel engine and a petrol engine. First major difference is, in case of petrol engine, air and petrol mixture is prepared outside the engine. Mixture is taken into the cylinder during suction stroke. But in case of diesel engine, only air is filtered and air is taken into the cylinder during suction stroke. Okay. Then remaining strokes remain same. Suction stroke moves from TDC to BDC. Air is drawn into the cylinder, during which the crank rotates through 180 degree. Okay. Then second stroke is compression stroke, where piston moves from BDC to TDC. Crank rotates through 180 degree. The compression of air takes place. Here the compression of air. Previous case, two-stroke, sorry, petrol engine, it is compression of air and fuel mixture. Here only compression of air takes place during the compression stroke, during which you observe both inlet valve and exhaust valve are closed. At the end of compression stroke, see here, this is the end of compression stroke. Piston is almost at the TDC, during which, see, the fuel injector, here in place of spark plug, there will be a fuel injector, diesel injector, which injects the diesel at high pressure at the end of compression. So when the diesel is injected to this air, which is at high pressure and temperature, this diesel starts combustion, starts burning automatically. So because the compression is so high here, that the temperature and pressure achieved are very high, so that at that high temperature and pressure, when the diesel is injected, automatically it starts burning. So it is also called self-ignition or auto-ignition engine, and also called compression ignition engine. Ignition takes place due to compression to high pressure and temperature. So then the fuel undergoes combustion, then starts the power stroke, TDC to BDC, 180 degree again rotation of the crank. Okay. So in this end, this is the end of power stroke. Then next stroke is exhaust stroke, during which the piston moves from BDC to TDC, during which you observe the exhaust valve is opened, inlet valve is closed, and this product of combustion are flushed out to the silencer and to the atmosphere. So during this exhaust stroke, exhaust valve is opened, piston moves from BDC to TDC, products of combustion are thrown out to the silencer to the exhaust. Hmm. So again, during which the crank rotates two rotations, sorry, 180-degree rotation. So here, suction stroke, 180-degree crank rotation, compression stroke, 180-degree crank rotation, power stroke, 180-degree crank rotation, then exhaust stroke, 180-degree crank rotation. Therefore, to complete one cycle, it takes 4 strokes: suction, compression, power, exhaust, 4 strokes, and during which it rotates 180 one cycle, then 180 two cycles. So it makes two rotations. The crank makes two rotations, piston makes 4 strokes to complete one cycle. Therefore, this is again a 4-stroke engine, and it works on diesel cycle. So it is called diesel engine, wherein only air is drawn into the cylinder during suction stroke, and at the end of compression stroke, diesel is injected at high pressure into the compressed air. And ignition and combustion is auto ignition, self ignition. This is how a 4-stroke diesel engine works. And this 4-stroke diesel engine was designed by Sir Rodolphe Diesel. So he designed that engine, and it works on this cycle called diesel cycle. Okay. So again, similar to auto cycle, there are same process. Say now here we'll say O2A suction stroke, where air is drawn into the cylinder. Then A to B, it is compression stroke. Air is compressed to high temperature pressure. Then B to C is heat addition, injection of fuel, and burning takes place, combustion takes place. But you observe it is B equal to C. Pressure at B is equal to pressure at C. So it is constant pressure heat addition process. So then C to D is power stroke, expansion stroke. Then D to A is constant volume heat rejection. In case of petrol engine, it is constant volume heat addition, constant volume heat rejection. In case of diesel engine, constant pressure heat addition, constant volume heat rejection. Therefore, this cycle is also called as constant pressure cycle. This is a diesel cycle. In the examination, the question is with the PV diagram or a standard diagram explain diesel cycle, then you have to draw this diagram and explain the various processes. Clear? Okay, now, so we will discuss about a two-stroke engine and working of two-stroke engines. So here, unlike four-stroke engines, the cycle is completed within 2 strokes of the piston. Okay. So here there will not be separate strokes for suction, compression, power and exhaust. All the processes will be completed in only 2 strokes of the piston and one rotation of the crank. Okay. So that's why this engine is called a two-stroke engine. Okay. So here now you see this black colored line. This is the engine cylinder. So and then cylinder is continued with a crankcase. This is called the crankcase, inside which this is the crank located inside the crankcase, and this is the connecting rod which connects the piston. So this is the piston. In red colored one is the piston is connected to the crank through a rod called connecting rod. And these fins outside the engine block or engine cylinder, these fins are provided for air cooling, effective air cooling. So in this Unlike a four-stroke engine, we don't have separate valves for inlet and exhaust. For inlet valve will be there. For exhaust, there will be exhaust valve for four-stroke engine. But here, all those valves are replaced with ports. Ports. Now you see, this is the inlet port, and this is the exhaust port. And one more here is the transfer port. Transfer port. So now I will explain you how it works. Now you see this is the engine cylinder. Okay, this is exhaust port, inlet port. Now initially, now in this, you observe inlet port is opened and air fuel mixture from the carburetor is drawn into the crankcase. In this case, air fuel mixture is not directly taken to the cylinder, but it is taken into the crankcase and collected. Okay. Then, now you see in the second diagram, the inlet valve is closed. Inlet valve is closed or covered by the piston. It is covered completely by the piston. So there is no inlet. Inlet port is closed. Then you observe the air fuel mixture is passing through a port. This port is called transfer port, through which air fuel mixture is transferred from crankcase to the engine cylinder. So this is called transfer port. Okay. So during which you observe the exhaust port is also opened. During which the piston uncovers the exhaust port also. What happens here is this fresh charge coming from the crankcase through the transfer port pushes the products of combustion. Now you see this is the products of combustion. It is pushed away through the exhaust port. So this process of pushing away the products of combustion by the fresh charge, fresh air fuel mixture. Actually, air fuel mixture is also called charge that pushes the products of combustion through the exhaust port. That process is called scavenging. Scavenging is the process of flushing out the products of combustion to the exhaust port used by the flush charge is called flushing, sorry, scavenging. Okay, so now next in this diagram you observe the transfer port is also closed, inlet port is also closed, exhaust port is opened, and okay, then compression starts from this. Now you see here all the ports are closed, air fuel mixture is compressed. At the end of compression, as usual, there will be ignition by using the spark plug. Spark is generated, ignition starts, and piston moves towards BDC, moves down. Okay, so that is called power stroke. So during at the end, say observe. So here the port is closed, the exhaust port is closed, but inlet port is open. So it starts drawing in the air fuel mixture. Suction starts. During the power stroke, suction takes place. Then next is transfer port opens here. Transfer of air fuel mixture to the cylinder. So then flushing out, then scavenging, then compression. So then power stroke. Along with power, suction takes place. Okay, this is how a two-stroke engine works. So in which there are two strokes, one rotation of the crank and completes one cycle. So this is how a two-stroke engine works. So now you observe in this case, as I told you, the inlet port is opened, the crank case is full of air fuel mixture, and transfer port is closed, exhaust port is opened, sorry, it is also closed. So power stroke starts and power stroke continues. Piston moves from TDC to BDC. Then when the piston comes to this location, this point, exhaust port opens. Okay, now we will see it in the next diagram. Say in this case, the exhaust port is opened, inlet is closed, transfer port is opened, and the air fuel mixture enter into the cylinder and flushes out the products of combustion. Okay, so that is called scavenging. Hmm. So then next is, so in this case, so the compression starts and compression continues. So at the end of compression, there will be fuel, spark generated by the spark plug. Ignition starts. So then power stroke starts, during which suction takes place. See, inlet port is opened, suction takes place. Power and suction simultaneously takes place. So then, therefore, so it completes all the four processes, but only two rotations of the two strokes of the piston and one rotation of the crank. So that is how a two-stroke engine works. Yeah, these are the four different diagrams or sketches. Then from your examination of point of view, the question is with need diagram explain the working of two-stroke engine. Then you have to draw all these four stages. Then you should make it clear that the port, see, when it is opened, when it is closed, all that should be clearly visible, especially the transfer port. So exactly at this point it should be opened and transfer takes place. And see, here it is closed. See, here it is closed. Here it is opened. Here it is closed. That way you should take care of the position of the piston, then angle of the crank, and the position of these ports, whether opened, closed, all that should be taken care properly. So practice to draw diagrams neatly. Then we will see some of the important differences between a two-stroke engine and four-stroke engine. So petrol engine and a diesel engine. Hmm. So in case of petrol engine, air and petrol mixture is drawn into the engine cylinder during suction stroke. In case of diesel engine, only air is drawn into the cylinder during the suction stroke. Point number two, a spark plug is used to ignite the fuel, hence they are also known as SI engines, spark ignition engine, petrol engines. In case of diesel engine, fuel injector is used to inject the fuel, hence they are called compression ignition engine or self ignition engine. Compression ignition because air is compressed to high pressure and temperature, so that at that temperature when the fuel is injected, so it starts combustion, ignition and combustion takes place. Point number three, the compression ratio ranges from 7 is to 1 to 12 is to 1, hence power produced is less. That means, what is compression ratio? It is the ratio of clearance volume to the total volume of the cylinder. What is clearance volume? There is the volume occupied uh, above the piston when the piston is at TDC. The clearance, the gap volume between the cylinder topmost position to the TDC. So that volume is called clearance volume, and the total volume when the piston is at BDC, the total volume of the cylinder. That ratio of clearance volume to the total volume is called compression ratio, and for petrol engine it ranges from 7 is to 1 to 12 is to 1, comparatively low to the diesel engine. Because in diesel engine the compression ratio varies from 16 is to 1 to 22 is to 1. Hence the power produced is more. So because of which two petrol engines are light in weight and diesel engines are heavy in weight. This petrol engine works on Otto cycle and also called as constant volume cycles. Then this diesel engine works on diesel cycle and also called as constant pressure cycle. The maintenance cost is less in case of petrol engine. Maintenance cost is more in case of diesel engine. Noise and vibrations are less in case of petrol engine. Noise and vibrations are more because of the high compression ratio in case of diesel engine. Petrol engines can be easily started in a cold weather because we use spark plug. But diesel engines are difficult to start in cold weather. The advantages of two-stroke engines. Two-stroke engines do not have valves, simplifying their construction. Construction is simple because there are no valves. Hmm. So two-stroke engines occupy less space. Then two-stroke engines fire once every revolution. For one rotation of the crank, one power stroke. So hence more power. This gives two-stroke engines significant power boost compared to four-stroke engine. Two-stroke engines are lighter and costs less to the manufacturer because the number of components are less. Because in case of four-stroke engine, we have to install valves, valve openings, then valve seatings, then some mechanisms to operate or open and close. Then the injector, which is to be designed and developed to inject the pressure at high pressure, inject the fuel at high pressures. Then compression ratio is more, so we have to design bigger engines. uh, so compared to four-stroke engines, two-stroke engines are uh, light. Two-stroke engines have less maintenance cost, less number of moving parts compared to four-stroke engines. Two-stroke engines are preferred in small vehicles, especially two-wheelers, bikes and all that. So engines lightweight and has high speed. These are some of the advantages of two-stroke engine or four-stroke engine. Disadvantages are since firing takes place in every revolution, time available for cooling is less. Cooling is a problem because there is continuous power stroke burning of fuel in every rotation of the crank. Hmm. So therefore, cooling time available is less, which results in overheating of the engines. Transfer port and exhaust port open during the same period. There is a overlap during which both the transfer port and exhaust port are opened. Whatever the fresh charge, air fuel mixture coming from the crankcase into the cylinder to the through the transfer port, some of that will escape through the exhaust port. So there will be some loss of fuel. So that leads to loss of efficiency of the engine. Hmm. So two-stroke engine requires a mix of oil in which the gas to lubricate the crankshaft, connecting rod, cylinder valves, etc. Two-stroke engines produce more pollution compared to four-stroke engine. Number one, because there is possibility of fresh air escaping through the exhaust port during scavenging. That leads to loss of fuel. So these are some disadvantages of two-stroke engine compared to four-stroke engine. Thank you very much. In case of any questions, you can contact me.